CSS sucks. If done good, it's actually really cool. But if done wrong, then 50 pixels looks meh, maybe 70, maybe 60, maybe 55, maybe 58. Maybe. And personally, units were one of the hardest things for me to grasp at the beginning. And so to figure them out, I taught myself all of them. And by the end of this video, you'll understand all the types of CSS units and know when to use each one of them every time. So let's go. Now, for the complete basics, what even is a unit? Units define sizes and proportions of each web element. They allow designers to control how elements are displayed in relation to each other and the viewport. And so we do this by using two types of CSS units, absolute units and relative units. Starting off with absolute units, these are the units that have an absolute fixed value and they don't change relative to the context or the environment. Just like a centimeter in real life, they represent a specific concrete measurement that does not change. Now, relative units are the complete opposite. They are flexible and are dependent on other factors like the viewport size or the size of the parent element, etc. So unlike absolute units where their values are concrete, relative units are based on a reference point. For example, 50% of this square is a lot more than 50% of this square. So now that we know the difference, let's start comparing each one of them. Starting off with our absolute units, let's talk about the pixel or px. The pixel is probably the most well-known unit among web designers, and it represents one single dot of the display, except with really high DPI devices, and DPI stands for dots per inch, where one pixel would represent more than one dot. And so we use pixels if we need really precise measurements, for example on borders or line height, or any fixed size element. So for example, if we have a small squared icon, to keep it that small and squared shape, we'd use pixels. And pixels are also used when specifying the viewport width and height, which is basically the size of the browser. However, try to avoid using them in terms of responsive design. Unlike other units, they don't scale with the screen. Next up, we have points, PT, and picos. I don't know, man. I don't know, man. Or PC. And honestly, you're probably never going to see these around or use them in your web development. They're usually used for print media, where 1 point is equal to 1/72nd of an inch, and 1 PC is equal to 12 points. So if you're using points, please stop. Or let me know down below what your reasoning is. I'm genuinely very curious. Next up, we have the physical measurements. So this includes the inch, IN, centimeters, cm, and millimeters, mm. Now, you probably will not be using these either, as they're usually made for print media, and they're based on the actual physical measurements. So 1 centimeters would be 10 millimeters, and 1 inch would be about 2.54 centimeters. And again, we don't really use these for web design, as they can be very unpredictable, and there's just way better units to use anyways. Now that we got the absolute units out of the way, let's talk about the relative units. And this is where it starts getting a little tricky. Probably the most common relative unit is the percentage, or percent unit. The value of the percent unit is relative to the size of the parent element. Now bear with me here. So for example, let's say I have two nested divs. The first one has a width of 400 pixels. Now, if I gave the second one, the one nested underneath, a width of 50%, it would take 50% of the value of the parent element, which is the first div. 50% of 400 is 200, therefore, the width of the second div would be 200 pixels. So percentages are amazing for sizing divs and containers and giving padding and margin relative to the parent dimensions. So they're great for responsive web design, but try to avoid using them with text as the results can become quite unpredictable. For that, you're better off using other units like the EM unit. And so for the majority of times, you'll use this regarding text, whether it be for the font size or line height, anything like that. EM is a unit relative to the font size of the parent element. This means that 1 EM is equal to 100% of the font size of the parent element. So say you have an element with a font size of 16 pixels. If you put your line height as 2 EM, then it would be double the font size. So the line height would end up being 32 pixels. If you had a div with a font size of 60 pixels and then decided to put text inside with a font size of 0.5 EM, then the text inside would have a font size of 30 pixels, which is half of the parent element. So again, use EMs when talking about font sizes, padding, margins, line height, etc. However, EM does get a little confusing when talking about nested elements. This is because the ratios compound each time you use them. So let's say I had 3 divs all inside one another. Pause. If I had the font size for the first div as 60 pixels, and then the font size for the second div as 0.5 EMs, then the text size for the second div would be 30 pixels. However, if I put the font size of the third div as 0.5 EM, then the text of the third div would have a font size of 15 pixels, which is half of its parent element, which is the second div, but it becomes 1/4 of the size of the original div. See how confusing that gets? So you have to be careful when it comes to that. But to avoid it, we have another unit called REM. The REM unit stands for root EM, and it basically acts like EM. However, instead of its size being relative to the parent element, it is now relative to the root, which is basically the HTML tag itself. So you're better off using this if you have a specific font size throughout your whole HTML document and you want to avoid the compound effect that EM has. Next up, we have the viewport units. Let's start off with VW and VH. VW stands for viewport width. One VW unit stands for 1% of your viewport width. And by the way, the viewport width is the width of the browser window. So let's say you want to make a banner, for example, you'd use 100 VW so that it takes up all the width of the screen. VH, however, is the viewport height. And again, 1 VH is equal to 1% of the viewport height. And so these are really helpful in making, for example, a hero section on a website, as you can set both of them to 100 to take up 100% of the screen. And oh my gosh, this is where the CSS units get really exhausting. But if you need a productive break from all these CSS units, you may be interested in trying today's sponsor, Brilliant. Brilliant is a learning platform with thousands of interactive lessons in math, data analysis, programming, and AI. It is the most effective way to learn, with each lesson filled with hands-on problem solving, which lets you play with concepts. Brilliant allows me to develop a powerful learning habit, even while taking a break from all of these CSS units. What's more is that you can even do lessons on the go right on their mobile app. And for my developers, Brilliant's growing number of programming courses are a great way to build foundations and learn real-life applications. Brilliant can help you develop your mind to think like a programmer with their Thinking and Code course. So you can actually start thinking like a programmer and begin writing complex programs to build games and apps. If any of this sounds interesting to you, make sure to check out Brilliant at brilliant.org/geodev or scan the QR code on screen for a full 30-day free trial plus an additional 20% off an annual premium subscription. Thank you so much, Brilliant, for supporting the channel. Now back to the video. Moving on to other viewport units, we have vmin and vmax. These are a little tricky to wrap your head around, so stay with me here. Let's talk about vmin first. Vmin stands for viewport minimum and is equal to 1% of the smaller dimension of the viewport. Basically, in your viewport, it looks at the size of the height and the width, and whichever is smaller, it gets 1% of that. Okay, I'm at the airport editing this video, and I just realized I explained this concept horribly, so I'm gonna try to re-explain it. We're gonna use my Firefox as an example, and if we click Command Option I, we'll open up the inspector, and on the top right, we can click on Responsive Design Mode, and we can close out of the inspector, and here we can play around with our viewport. So up top, we have our two values, our width and our height. And so obviously our width is larger than our height. And what vmin does is it looks at the smaller of the two values. So because our height is smaller than our width, it would look at the value of the height. And remember, 1 vmin is equal to 1% of the value of the smaller dimension. So 1 vmin would take 1% of this value. So it'll be around 7 point something pixels. And Vmax is the exact opposite. So because our width is larger than our height, it will look at the larger value, and so the value of the width. And 1 Vmax, it will take 1% of that, and so this would be around 13 point something pixels. So I hope that clears it up, and if you have any questions, just look at the documentation, so I don't know. So when would you ever use these? Well, you'd probably want to use vmin in, for example, responsive typography to ensure that whatever text you have on the screen adapts appropriately. And then also an overall responsive design. So typically when you want to have certain elements be the same and look consistent in both orientations. Or if you want, for example, shapes like squares or circles to remain even, regardless of the viewport. Now this next one is a little niche, and I've personally never used it myself. We have the EX unit. This unit is relative to the X height of the current font. Now the X height refers to the height of the X letter of the given font. And if the browser can't determine that because it's a certain kind of font, then it automatically defaults to about 0.5 EM. Now, you'll probably never use this, but it's really cool. Now, following with the X, we have the CH unit. Kind of like the EX unit, CH is also relative to the current font that's being used. However, instead of depicting the X height, it depicts the width of 0. And this is useful for styling predictable elements that have a specific width. So say you have a form with a date or a 4-digit pin. And now for our last unit, which may be considered a little bit of cheating, we have FR, or fractional unit. FR is exclusive to grids, which honestly deserve a whole video on their own, but it's still pretty important to understand how it works at least. It represents a fraction of the available space in a CSS grid, and they're used to divide the grid proportionally. Let's say we have 3 columns, automatically CSS will adjust so that each column has the same width. However, if we specify that the first column will take 1 FR, the second will take 2 FR, and the third one will take 1 FR, we've essentially split up the grid in 4 parts, where the middle column takes 2 of them. Again, this probably deserves its own video, but it's definitely important to know, and I think it's really cool. That's all from me today. Thank you so much for sticking around. If you learned something new, definitely let me know by leaving a like and consider subscribing. Comment down below what your favorite or least favorite CSS unit is, and if you already knew what all of these did. And with that, I'll see you next time. Bye bye.